So now that I've showed you how to do it the slow way, I'm going to work this the fast way. So we'll quickly label our nodes that I went over, V1, V2, and we'll keep this 4 volt as 4 volts. So we can write this directly into matrix form real quickly. And the way you do it is you kind of have to keep track of everything that's going on. So you're going to write out your matrix kind of like that, and you're going to label your columns V1 and V2. We'll call this supernode internal and supernode external. Now the big thing to remember is you might not get a nice circuit like this one that Dr. Irwin gave you guys on the first test where all the resistors are 1K. So when that's the case, then the resistors might actually be other numbers, and you're always adding up the reciprocals when you're doing nodal analysis. So what we'll do is we'll look at the circuit and we'll say, well, we know the constraint equation, which is just going to be 1 for V1 minus V2, and that is equal to 12 volts. So we wrote that down. It's a gimme is what I always call it because it's so quick and easy to do that one. You just go from the voltage at the positive side to the voltage at the negative side, and it's equal to the voltage that is listed above the voltage source. So the next thing we need to do is sum in all the reciprocal, the sum of the reciprocals of all the voltages going, the currents going in and out of the supernode. So at the V1, we see real quick that we have this guy and this guy. And so the sum of those two reciprocals are for V1 is going to be 2. So we just write down a 2 for V1. Now what we're going to look at is V2, and that's going to have, again, this guy and this guy. So we'll write down the sum of the reciprocals, which 1 over 1 plus 1 over 1 is equal to 2. Now if it was 2K, then you would say 1/2, because you're basically saying 1 over 2. The reciprocal of 2K would be 1 over 2. Okay, so you would write down 1/2, but in this case it's also just the 2. Now those are all the things basically that we defined as leaving the supernode. Now everything that it went to, we have to write down as negative numbers. So in this case, it's just going to be this voltage right here, because that's the only thing that it goes to other than ground. So normally you write that down as the negative voltage. So say this was a, for example, like say this node was a V3, you would write down minus V3, and you would sum how many times it touches V3 or whichever other node. But since we know, in this case, already what the voltage is, we know it's going to go to the other side. So we have a -4 and another -4 because it gets touched twice. Once by this branch and once by this branch. So we have a -4 and a -4. That's equal to -8. When we take it to the other side of the equation, that's going to just be equal to an 8. And once again, if you plug that into MATLAB or your TI calculator, you should get the answer, which is going to be 8 and -4. Now that you have that, like I showed in the previous video, you can just basically say that V1 is 8, so 8 minus 4 equals to over 1K is equal to the current, and that's the current basically going through this branch right here, and that's going to be equal to 4 milliamps. So we know 4 milliamps is going through here. And then if we do the same thing on this side, then we know that's going to be V2, which we found to be -4. And then we know the voltage right here is -4, so that's -4 again. And that's over this 1K. So 1K, well, that's equal to -8 milliamps. So since there is -8 going in this direction, there's -8 there. We really know there's 8 going in that direction, right? And we know that there's 4 going in this direction. So if there's 4 going in this direction and 8 in that direction, it means there has to be 4 milliamps coming up through this So we know that's going to be 4 milliamps being supplied because it's leaving out of the current source. There's 4 milliamps supplied. So the power is simply I times V, which is going to be 4 milliamps times your 4 volts, and that is equal to 16 milliwatts. And like I said, it is supplied because it's leaving. And that's it. Really quick. Didn't have to write down any equations to do nodal.